In this video, we're going to talk about parallel and perpendicular lines. Let's first talk about how the slopes of two lines are related when lines are parallel. We have here that line y sub 1 is parallel to line y sub 2 if the two slopes are equal, yet they have different y-intercepts. So we have two lines that have exactly the same incline. They're growing at the same rate. So the graphs of those lines are not going to ever get closer or further apart from each other. Yet they do have different y-intercepts, which makes them two distinct lines. Let's look at how to determine whether two lines are perpendicular. What does it mean for two lines to be perpendicular? That they intersect at a very special angle. They intersect at 90-degree angles. For two lines to be perpendicular, the product of their slopes should be -1. How do we know if the product is -1? Well, there's an easy way to check. If the slopes are opposite reciprocals of each other. So for example, if you have one line with a slope equal to positive 2/3, then a line that is perpendicular to that one would have to have a slope equal to -3 divided by 2. So notice that the two slopes have opposite signs and that the magnitudes are reciprocals of one another. There is one exception to this rule. Of course, every horizontal line is perpendicular to every vertical line. However, this product of slopes being equal to -1 does not apply in this special case because horizontal lines have zero slope, vertical lines have undefined slope. Clearly, 0 multiplied by undefined is not -1. So that is one exception to the rule. In the next few examples, we're going to look at equations of lines and determine whether these lines are going to be parallel, perpendicular, or neither case. And we're going to do this by rewriting the equations in slope-intercept form so that then we can compare the slopes of the lines. In the first example, we have 5x minus 2y is equal to 12. To rewrite this in slope-intercept form, we are going to need to isolate the y variable. So let's start by subtracting 5x from both sides. One more step to isolate y, divide both sides by -2. So finally, we have that y is equal to positive 5/2 times x minus 6. Note that in this case, the slope of this first line is a positive 5/2. Now let's do the same thing with the second line. Its equation in standard form is 2x plus 5y equals 1. Let's rewrite the equation in slope-intercept form by isolating the y variable. We'll start by subtracting 2x from both sides. And next, let's divide both sides by 5. So, written in slope-intercept form, we have that y is equal to -2/5 times x plus 1/5. Notice that in this case, the slope of the second line is a -2/5. Because the slopes are opposite reciprocals of one another, we will find that multiplying the two slopes will indeed equal -1. Therefore, these two lines happen to be perpendicular. Good. Let's move on to the next example. We have the first line with equation y equals 1, the second line with equation y equals 3. Well, both of these lines are already written in slope-intercept form. And these are special cases. Both of these lines are horizontal. They both have zero slope. Because their slopes are equal, and more conceptually because they are both horizontal, and yet they have different y-intercepts, these lines are parallel. All right, let's take a look at the next example. We have y is equal to 2x plus 4, and x minus 2y is equal to negative 3. By now, hopefully, you'll get the hang of what we're doing. We're going to rewrite both equations in slope-intercept form. In this case, the first one already is. So we just have to manipulate the second equation. Let's subtract x from both sides and divide both sides by negative 2. So the second equation becomes y is equal to positive 1 over 2 times x plus 3 over 2. Notice that the slope of the second line happens to be positive 1/2. Going back and looking at the first equation, we find that the slope of the first line is positive 2. Well, in this case, the two slopes clearly are not equal, so these are not parallel lines, but they're also not opposite reciprocals of one another. They are reciprocals of one another, but they're both positive, so they don't have opposite signs. So in this case, these lines are not parallel. They're also not perpendicular. Neither case is true. Now, if we think about what the graph of these two lines would look like, we do expect them to intersect, but they would intersect at an angle other than 90 degrees. All right, let's look at the next example. Again, let's rewrite both equations in slope-intercept form. We'll start here by subtracting 2x from both sides and then dividing by negative 1. So here we have that the slope is a positive 2. Let's use that one subscript so we can distinguish between the two lines. In the second case, we already have slope-intercept form. We have y is equal to positive 2x plus 14. So in this case, the slope is also a positive 2. So these two lines have exactly the same slope, and yet they do have different y-intercepts. The reason we look for different y-intercepts is we want to make sure this isn't the same line, that these are two distinct lines. And so in this case, we do have two distinct lines that are parallel. In the next example, we have x equals 1 and y equals 0. The first line, x equals 1, describes a vertical line. The second equation, y equals 0, describes a horizontal line. In fact, y equals 0 is the equation for the x-axis. We know that every vertical line will be perpendicular to any horizontal line. However, we're not going to worry about the slopes. We just know this conceptually. Again, a vertical line has undefined slope. A horizontal line has 0 slope. The product of those two slopes is not going to be negative 1, but this is the exception to the rule. These two lines are going to be perpendicular. So I want you to think beyond the mechanics. I do want you to think conceptually about the work that we do. In the next example, we're asked to write equations of two different lines. First, a line that is parallel to y equals 1/6 x minus 4 and passing through the point negative 1, 4. Secondly, we'll write the equation of a line that's perpendicular to the given line and still passing through the same point. To be able to do this, we're going to recall the point-slope form for the equation of a line. I'm going to write this up top just for your reference. And I'm going to use a different color here for y sub 1, m, and x sub 1, because those are the values that we will need to substitute into this point slope form. So let me name this here for study purposes. Good. All right, let's start with a line that is parallel to the given line. The given line has a slope equal to 1 over 6. So if I want to find the equation of a line that's parallel to this one, then I need to use exactly the same slope. So in this equation, I'm going to substitute 1 over 6 for m. I'm also told it has to go through this ordered pair, -1 for x and +4 for y. So I am going to substitute -1 for x sub 1 and +4 for y sub 1 in the point slope form. So this is what it should look like. Y sub 1 is 4. M, because we're trying to be parallel to the given line, we're going to match the slope. We'll make that 1 over 6. And x sub 1 is a -1. Now all we have to do is use algebraic manipulation to clean this up a bit and write it in slope-intercept form. First, I'm going to clean up that right-hand side. Oops, that's a misprint. Let me use the correct sign there. X minus a -1 is going to be written as x plus 1. Now, let's distribute the 1/6 on the right-hand side. So we have 1 over 6 times x plus 1 over 6 times 1. And to isolate y, we're going to add 4 to both sides. So we'll have y equals 1 over 6x plus 1 over 6 and plus 4. Now let's combine these like terms. 1 over 6 and 4 are both constants. To be able to combine them into a single term, I'm going to rewrite 4 as 24 over 6. Finally, we see that y is equal to 1 over 6 times x plus 25 over 6. We're going to use a very similar process to find the equation of a line that's perpendicular to the given line and still passing through the same ordered pair. What will be different in this case is that whereas we tried to match the slope to make the original line parallel to the given line, in this case, we're going to use a different slope. We're going to use the opposite reciprocal of 1 over 6. So here we're going to use a -6 over 1, which can be written as just -6. So we're going to go back and use the same point slope form. And because we're still trying to pass through the point -1, 4, we're going to make the same substitutions for x sub 1 and for y sub 1. What will change, however, is right here, our slope is now going to be -6. So from here on out, we're just going to use some mechanical work to write this equation in slope-intercept form. So we have y is equal to -6x minus 2. That is the equation of the line that is perpendicular to the given line and passing through the given